The purpose of our robotic magnetic manipulator is to follow the user's commands and to mimic human actions by moving metallic objects around.
We wanted to build a robot that would mimic human hand movements such as a robotic arm. Due to limited resources, we had to simplify our idea to a magnetic manipulator robot which would use sensors to accurately move according to the user's input. The user would be able to control the robot from a distance through a webcam, which would allow them to see the surrounding of the robot and help them guide them to their desired locations. The user will control the actions of the robot using remote sense that will work based on force sensing resistors. The robot would be controlled using four force sensor resistors, two of them which will be on the pulley to elevate and de-elevate the magnet, which would come in contact with the metal, and the other two would be used to control side-to-side motion of the servo. We will perform calibration of the force-sensitive resistors by taking readings of known weights to compare its precision. The user sends out a signal by pressing on the force-sensitive resistor, which sends the changes in resistance to the transducer. Then during the sensor-transducer stage, sensors input from the force-sensitive resistors will be read, providing an analogous output in terms of change in resistance. During stage 2, the transducer will convert resistance to a voltage which can be read by the final stage. The amplifier will increase the amplitude of the signal and/or the power. Then the unfiltered data will be passed through a low filter pass to exclude any unwanted noise, also known as high frequency. This data will be read out and recorded on the computer by LabVIEW using the help of the Data Acquisition System and the Quanser Rapid Control Prototyping Toolkit.
Sensing mechanism. Force sensing resistor allows you to detect physical pressure based on how much weight you apply on it. The sensor has two layers, which are separated by a spacer. As the force that is applied increases, more of the active element dots touch the semiconductor, causing the resistance to decrease, and therefore creating a correlation between force applied and resistance. The resistor comes in three different shapes: square, circle, and strip. Our robot also consists of Quanser SRVO2 rotary servo base unit, which consists of three sensors: potentiometer, encoder, and tachometer. The potentiometer and the encoder measure the angular position of the load gear. The tachometer is used to measure its velocity. If further developed, our magnetic robot manipulator has great potential. The magnet can be replaced by a claw or hand, and the robot can be made mobile. More advanced sensors can be used to increase the abilities of the robot. For instance, it can be used in industrial sorting of metallic objects from a distance, or with the upgrade suggested, it could be helpful for research purposes in unsafe environments for humans, such as places with radiation, mining sites, and harmful chemical labs. It can also be used for diagnostics of contagious diseases.